Good morning. Thank you for joining us today at the second annual EDGE Sustainability in the Next Generation Workforce Conference. I think everybody's coming in right now, so I'll give everyone a second to get into the conference. Before we get fully started, I see that the web is still rolling in attendees. Okay. So we're very excited to bring you this virtual conference today. My name is Kristy Nguyen, Senior Director of Programs and Development at Reiss. In the chat right now, you will find a link to the agenda for today's conference, as well as the bios for the speakers today. Please click the link to download it to your device. EGE, this is what some people call us, but it's actually pronounced EDGE, which stands for Engineered Green Economics. And it's an initiative of the Wise Institute, our signature college and career readiness program. This year, not only are we doing this conference virtually, we're also partnering with City Atlas, Con Edison, the UFT, the Paleontological Research Institute, and the Urban Future Lab, because we want to continue to increase opportunities for stakeholders, from education to community organizations to businesses, to work together for a better tomorrow. Thank you all for joining us today. So some housekeeping first. In the chat, again, you've been provided the agenda if you just joined us, so you can go ahead and download that. Simply click the link and you can download it to your device. Additionally, for teachers who would like to receive your CTLE credits, we will provide a link also in the chat to download a special survey. This link is only available in the last 15 minutes of the event during the panel discussion. The link will not be sent out or be available after the event. So at that time, at the end of the event, please download your survey from the chat onto your computer, complete it, and email it back to me. My email is on the form. Upon receipt of the survey, we will email you back your CTLE certificate. So we know that's very important to you, and we will be very efficient with that. So thank you so much. Without further ado, I would like to introduce Phyllis Perillo, the President and CEO of Wise, to officially welcome our attendees and speakers today.
Greetings, and thank you for attending. I think you will all agree that this is a difficult year. For sure, there is uncertainty and a real need for change. Because of COVID-19, Wise pivoted so that we could move forward in providing our programs, services, and events. We didn't want to disappoint, and we are proud of successfully working in partnership with schools for 22 years, bringing cutting-edge materials and resources to educators. Now I have to tell you a story, a personal story. Many, many years ago, before Wise, before the National Academy Foundation, before working for the Chancellor of New York City, I was a high school educator and school administrator in Queens. As a young educator, I was selected to be one of 3 New York City educators to teach a new hot subject: computer languages, Fortran, COBOL, and RPG. It was exciting to be ahead of the curve, to give young people insight and instruction with a new subject, to open their eyes to wonderful career opportunities, and potentially a major in college. Now it's your turn. WISE firmly believes that sustainability and resilience is so important, now more than ever. And it is the new, hot, and growing career field. We have an amazing program for you today. You will hear from incredible minds and representatives from institutions of knowledge. We have Dr. Ingrid Zabel from the Paleontological Research Institute, a partner of Cornell University. She will walk you through selected lessons from her book, The Teacher-Friendly Guide to Climate Change. You will hear from our conference partner, City Atlas, who will introduce their truly exciting game, Energetic. Kristy Nguyen will return to talk about EDGE, a WISE Institute initiative that can help you bring sustainability education to the classroom. And lastly, we'll have a panel to discuss, a panel of experts and leaders from industry. The panel will be moderated by Harun Assad, Head of Sustainability at Edison, and also the chair of our EDGE Advisory Committee. We have a special bond with Con Ed, our foundational partner that supported the initial development of EDGE. Joining Harun are panelists Isil Akgul, designer at Cooper Robertson, Mark Chambers, director of the Mayor's Office of Sustainability, David Davenport, managing principal of Urban Greenfit and SVP at Urban American Management. And lastly, Dr. Peter Kalmus, climate scientist at NASA. I thank them for joining us and sharing their expertise. I also extend special appreciation to our funders, Wells Fargo, Con Ed, Sterling National Bank, and Valley National Bank. Of course, I tip my hat to our wonderful WISE Board of Directors and a very talented staff. Kristy Nguyen and Sheila Beatty, who organized this conference, as well as other producers, David Anderson, Mike Castrilli, Kyla Duarte, Samantha Spina, and Luis Romero. Finally, I close with a salute to our heroes, the teachers. And I ask them, please join us in developing a new mindset for a better tomorrow. Thank you.
Good morning, everyone. My name is Sterling Robeson, Vice President for Career and Technical Education for the United States Federation of Teachers. I bring each and every one of you greetings on behalf of Michael Mogul, President, and all of the officers of the UFT and the 208,000 members that we represent. This is one of the hardest years to be an educator in decades. At the United Federation of Teachers, we know and we're here to serve and support you to make education stronger. That is why we are proud partners and sponsors of the WISE programs, which bring rigor and opportunity to young people and preparing them for college and careers. We can all agree that educational equity is a key factor in bringing a better future. Students need to have opportunities to learn higher level material that will advance their careers and livelihood. WISE programs are open to everyone. In fact, I know that they pound the pavement asking to bring programs and augment classroom learning and bring real world perspectives and relevant experience to high schools across New York City. The Wise Edge Conference is relevant and timely. Clearly, there's a tremendous need for sustainability education to be integrated in all of our career and technical education programs, not just here, but across the country. Also, it needs to be incorporated in a number of disciplines, including not just the science, technology, engineering, and math, but also the economics and humanities. And we know teachers are essential, key to preparing our young people to meet the challenges of tomorrow and molding them to be the future leaders and innovators that we know they're destined to be. As seen in the past, we know that the demonstrations the recent demonstrations on climate change, and students are asking adults to step up and do their part by way of saving the planet and protecting their future. This is where education can make a difference and be the pivotal changes for the next generation. So to all of you, I commend you for stepping up and aiding all of our students as they seek their place and their contribution into society and the environment, as well as the economy. I want to applaud the participants today for their expertise and knowledge. A special thank you to the partners and stakeholders in the audience for attending. You will learn how you can help further sustainability education for our students. So I do indeed thank you. Next, we will hear from 3 presenters. Each will introduce you to tools that will help you teach sustainability. Our first presenter is Dr. Ingrid Zabel, a physicist and climate change education manager at the Paleontological Research Institute affiliated with Cornell University. Dr. Zabel.
Thank you. I am going to share my screen and start a presentation. All right, so today I am going to start by telling you a bit about myself so you sort of know where I'm coming from, and then give you a brief overview of a book that my colleagues and I have written to help teachers who want to teach about climate change. And then I'll run through a few activities, one of them that all of us will do together here, and then 2 others that I'll just sort of show you, but things that might be of interest in your classroom. All right, so as the name of my organization suggests, our focus is about the history of life on Earth. And we have a large collection of about 3 million fossils that our staff and other researchers use for scientific studies. But we also have education and outreach staff, and I'm part of that. And we teach at 2 venues in Ithaca. One is a small natural history museum called the Museum of the Earth. One is a nature center, the Cuban Nature Center. And the focuses of our outreach and education are on earth system science, environmental education, evolution, and climate change. And climate change is what I work on. So just again, to give you an overview of what we do in climate change education, we help run and participate in youth climate summits. I curate an online clearinghouse for climate change science data for New York State, which is not really intended for teachers, but it has a lot of resources that teachers could use. We teach about climate change and weather at a summer camp at our nature center. We help people get involved in citizen science projects. We have exhibits on climate change and energy. We run teacher professional development workshops. This is one from New York City, actually, a few years ago. And we run programs for students and the public, and we write books. And so this is the book I'm going to talk with you about today, The Teacher-Friendly Guide to Climate Change. So this book was written to talk about both climate science, but also the social science issues of teaching climate change and some of the obstacles and barriers. It was a project funded by the National Science Foundation So because of that, we make it freely available. And I have a shortened link right here. So if you go to this link, you'll find one of our web pages where you can download a free PDF of the book, or there's a link to if you want to purchase a hard copy. And it's not a textbook. I would say is more of a sort of reference book or guide for teachers who maybe are teaching about climate change but want to learn a little bit more about certain subjects, or maybe they've never taught about climate change and they want to know how to get started. So I'm just going to run through the table of contents just to give you a flavor of what's in the book, and then we'll move on to our activities. So the first chapter is kind of an introduction and talks about, why should we teach about climate change? Why is it important? In the second chapter, we went to experts around the country, actually internationally as well, and we asked them this question: if you could only impart one thing about climate change and energy, what do you think is the most important thing that people need to know? And we compiled all their answers in this chapter. So it's really good food for thought and thinking about, what should I focus on? What are the key things one needs to know? And then the next few chapters are on the basics of climate science. So what is climate? So before you can talk about climate change, you have to understand what climate is. How is it different from weather? How do we measure climate? Those types of things. And then we have a chapter on climate change through Earth history. So this is going back into deep geological time and looking at changes that have happened in the past. And that's really useful for giving context for the change that is happening now and understanding causes, which gets to the next chapter, which is evidence for and causes of recent climate change. So here we're talking about in the last few decades, or maybe the last 100 years or so, what is happening now and why is it happening? And then we have a chapter on US regional climates. So our thinking is that if they're teachers in different regions of the United States, they might want some information about the climate in their region and what are future projections for changes in their region. And then we have 3 chapters about solutions. So climate change mitigation. So this is a kind of a broad survey of solutions, ways to try to reduce future climate change. Geoengineering, so that is about large-scale technological interventions into the Earth's climate. Many, I think, which are poorly understood, but we need to start talking about it because this may be part of our future, the response to climate change. And then adaptation. So climate change is here, it's continuing to happen. How do we live with it? How do we cope with it? How do we become more resilient? And then the book returns to some of the social science issues. So obstacles to addressing climate change. So here the focus is on maybe some of the psychological issues. What are biases people have that get in the way, both students and teachers? What are some fallacies that people are prone to? Chapter 11 we call perspective. Here the focus is on, I would say, apocalyptic thinking, and if that's a useful way or not to talk about climate change. And then finally at the end we have a frequently asked questions chapter, which can be very useful for pinpointing specific issues. So again, that's a broad overview of our book. And now I thought I would get to some activities, and I'm going to run through a few activities that I call Scale Bootcamp. So why talk about scale? Climate change, as with other intellectual pursuits, learning about it or other issues, is one where scale is really important and understanding scale. And many of us, myself included, don't always have a good intuition for scale when it comes to the very small or the very large. But it's really important to at least try to understand it. So I wanted to show you a few activities to get us thinking about scale. And the first one, I'm going to use Whiteboard through Zoom, and I'm going to make a drawing, and then I'm going to ask you to draw on top of my drawing. So all of you participants, you should be able to do that from your computer or your phone if you're joining on your phone. But in case you haven't used Whiteboard before, I created a tiny little GIF tutorial just to show you what you're going to need to do on your end. So I'll get to that in the next slide. It's a GIF and it'll just keep looping through and I'll talk through it. You might see the name Mark Zabel. It says you are viewing Mark Zabel's screen. That's just because when I made the GIF, I was testing out with my husband, Mark. So, but you can just ignore that. It's not relevant here. All right, so here's a little GIF. So after you see my whiteboard, you'll see this screen. You go up to the top where it says View Options, and you'll select Annotate. And when you select Annotate, you'll get this toolbar up here, and you'll select Stamp. And this went kind of fast, so we'll go through it again. And that will allow you to make a little stamp on my screen. So again, your screen should look like this. You go up, you select Annotate. There's your toolbar, and you go over to Stamp, select the X, and then when you click on your screen, you'll be able to make a little X on top of my drawing. All right, so I think I will stop this now. Although I should say, if you are participating through a cell phone, I don't think you'll have the stamp option. You might have to just draw an X using the pen option. But if you're on a computer, you should see this. All right, so I'm going to stop this share. And now I'm going to share my whiteboard. Okay, so hopefully now you are just seeing a blank white screen. And I'm going to draw something on it. I'm going to draw a line. This. And then I'm going to write 0 on the left end. And I'm going to write the text again. 1 trillion on the right end. So this is a number line. And then I'm going to put some instructions, just paste them in here. So what I want you to do is to, using what I just showed you, click on the number line where you think the number 1 billion belongs, between 0 and 1 trillion. So you can all start now, and I don't know, I'll give you maybe 30 seconds to just start clicking. And this is anonymous, but we should hopefully start seeing a bunch of little X's come up on the line as you're clicking. I don't see any X's yet, so I hope people aren't having trouble with the technology. Ah, there's an X. Oh, there's something in the chat. Let me see other questions. Someone said, I don't think it's working. Someone did it. Yeah, maybe some people are having trouble annotating. All right, well, we'll wait a little bit longer, but if you're not able to click, what you could do is just do it on your own with pencil and paper, or just in your mind, think, where does 1 billion belong on this number line? But we'll wait a few more seconds and see if a few more people are able to click on there. All right, so I think this group actually did better than I've seen when we've done this, when I've done this activity before with a bunch of science teachers of different fields. So what I've seen before sometimes is people clicking over here, maybe about 2/3 of the way along the line. So you've done better, but these answers are still not correct. So if you think about it, what's the relationship between 1 billion and 1 trillion? Well, a trillion is 1,000 billions. So imagine dividing this line into 1,000 pieces. Where would 1 billion go? Well, it would go, and I'll just put a star, I guess. It would essentially go here at 0. Okay, so because if you divide this line into 1,000 pieces, each little division is going to be tiny. So, so I would say a lot of you got it wrong, but you're not alone. And these are hard numbers to fathom. A lot of us, I think, can understand 1,000. You know, maybe a computer costs $1,000, maybe a high school might have 1,000 students. We sort of have an intuitive feel for that number. But when you get to 1 million, or certainly 1 billion, 1 trillion, those numbers are very hard to fathom. I don't have an intuition for what 1 trillion really means. We've been hearing that number a lot recently in economic news in the response of the government to the pandemic. So it is important for us to understand what those big numbers mean. And it's important in climate change too. All right, so I'm gonna stop sharing this, but this is an activity that you could imagine doing with your students. We usually do it in a room, and we do it on a wall, and then give the students sticky notes, and they stick notes on the wall, and you can ask them to stick on 1,000 and million and billion, not just 1 billion. All right, I'm gonna share my presentation again. Oops, sorry, I ended up in the wrong spot. Okay. So I'll go to my next slide, and I'm going to show you another activity having to do with the scale. And this one is directly about climate change data. So what you're seeing here is a graph, a very important graph to understand, to try to get a sense of what's happening with climate change today relative to the past. So there are two things plotted here. The scale on the horizontal axis is time in years before the present, and it goes from 800,000 years ago to today. And what you see plotted in red is the Earth's average surface temperature in Fahrenheit, and that scale is on the left side of the plot. And then carbon dioxide in the Earth's atmosphere, and that in parts per million, and that scale is on the right. And just briefly where these data come from. So most of the data you see here come from an ice core record in Antarctica. So science drilled down into the ice where it's very deep in Antarctica. They pull up a core, sort of a cylinder of ice. And the deeper you drill, the farther back you go in time. And it turns out that there are layers in the ice, sort of analogous to tree rings. So you can actually track time going down and count year to year. And you can do chemical analysis of the ice to get temperature in the past. And you can look at little air bubbles that got trapped in the ice to get carbon dioxide from the past. So a few things to notice here. In the past 800,000 years, you see maybe these cycles of temperature and CO2 going up and down, up and down. And you might notice also that carbon dioxide and temperature seem to move up and down together. And that's because carbon dioxide in the atmosphere is the main driver of Earth's climate. So generally, if you look at the geologic history of Earth, when CO2 is high in the atmosphere, the Earth is warm. When CO2 is low in the atmosphere, the Earth is cool. And then the final thing to notice is the recent past. So it may be hard to see on this, but the blue line goes way up here in the recent past to just last week, carbon dioxide was close to 416 parts per million in the atmosphere. So that's certainly noticeable that the recent changes are really out of whack with the geologic past, at least in the last 800,000 years. There have been times before when CO2 in Earth's atmosphere has been this high. The last time was about 3 million years ago. And certainly life went on, but our species, Homo sapiens, didn't exist yet. All right, so it's interesting to look at the magnitudes, but let's also look at the rate of change. So let's compare the rate of change of CO2 in the atmosphere in the recent past, say the last 100 years, with some other time in the past when there was a rapid change. And I picked this time where it looks like CO2 jumped up very suddenly. And let's look at the difference between those rates and let's calculate them. So to calculate a rate, you have a change in some variable over a change in time. And for this particular data set, for this time period when CO2 jumped up, it jumped up 93 parts per million in about 11,000 years. In the recent past, last 100 years, CO2 has increased by 104 parts per million. So you could do this calculation, and I won't ask you to do it right now, but you can actually kind of ballpark estimate in your head. You could, if you look at this, it went up by about 100 parts per million in about 11,000 years. Here it went up about 100 parts per million in 100 years. And in the next slide, I'll just show you the answers. So basically, these rates differ by a factor of about 100. So the rate of change of CO2 now, because of what humans are doing in our, by burning fossil fuels, is about 100 times faster than the fastest rate of change in the last 800,000 years. It's really an unprecedented high rate of change. And that is sobering, but I think it's an aspect of scale that we need to understand, how fast things are changing. All right, one other example. Let's see, I've lost a little track of time. Do I still have a few minutes? Well, I'll keep going just for, let's see, there's a comment here, chat. I just want to make sure I'm not using up other people's time. I'm not able to see the chat, but I'm trying to see. Yeah, I'm sorry, I can't see the chat. I'm going to just try to go on quickly, unless if someone can let me know if I am out of time, I will stop. So final scale example having to do with the greenhouse effect and trace gases. So just briefly, you may have heard of the greenhouse effect. This is why our planet is warming. So this is a picture of the Earth and the atmosphere. The atmosphere is not to scale here, so really the atmosphere is a tiny, very thin layer around the Earth, but I've just made it look thick here just so I can draw these pictures and have you see them. So the greenhouse effect. So the sun shines on the Earth and warms it, and there's an energy balance. So the energy coming in from the sun has to be balanced by energy going out from the Earth. And the energy radiated by the Earth is infrared radiation. It's called long wavelength infrared radiation. And that's what I've tried to show with these arrows coming out from the Earth. And there are molecules, gases in the atmosphere that absorb that infrared radiation. For instance, carbon dioxide. Other examples are water and methane, but I've just shown carbon dioxide here. And of course, there are other molecules in the atmosphere, oxygen, nitrogen. They're much more abundant than CO2, but they don't absorb that infrared radiation. And when these molecules absorb it, they start to vibrate and they re-radiate it. Some of it goes back out to space, goes in all directions. And when they start to wiggle around, they'll bump other molecules and the temperature of the atmosphere increases. And that's how our atmosphere warms. So my colleagues and I taught a course on climate change last summer for some adults. And there was a gentleman who had a question about this because we talked about trace gases, the fact that really carbon dioxide is a very small proportion of the gases in the atmosphere. And in fact, as I showed you before, currently the CO2 concentration in the atmosphere is about 416 parts per million. And that's parts per million by volume. So imagine you had a cube, say it's 1 meter square, and you break that up into 1 million little cubes inside. Only 416 of those would be filled by CO2. So a gentleman heard that and he said, so you're talking about this cube that only has a tiny percentage of the space filled by CO2 molecules. Well, is it possible that this radiation coming from the Earth would sort of pass through a cube of air and never intercept one of those molecules? So maybe the greenhouse effect isn't really right the way it's described. Interesting question. But another way to think about it and think about the scales is, okay, well, let's think about if you take a bottle, say a 1 liter bottle, how many CO2 molecules are actually in a 1 liter bottle of air? And you can do that calculation. And if you're interested, I can send you a link to a write-up of that calculation. And it turns out that in that bottle at standard temperature and pressure, there are about 10 to the 19th carbon dioxide molecules. So that's about 10 billion CO2 molecules in this bottle of air. So there's no way that radiation coming from the Earth is not going to meet one of those molecules, in fact, many of them. And maybe it's confusing too that we use a model with these little squiggly arrows to indicate the radiation. So sometimes we have to be careful with these cartoon drawings because they give people ideas which may not be reflective of reality. So just another example of scale and how it's important to understand those numbers. I will finish up and just say thank you. And if people have questions for me, I have my email if you want to contact me, or you can certainly connect with Kristy if you want to relay questions to me. Thank you.
Hi, it's good to meet everybody. And thank you, Dr. Zabel. Actually, what I've heard so far this morning has given me a lot to think about. So I run a project called City Atlas, and we designed this game about the future of New York that we're going to show you a little bit of. First, I wanted to give you some background on how our project got started. So if you excuse me, I'm going to screen share. Just want to make sure I have, there we go. So we started in 2011, and we're partnered with the Institute for Sustainable Cities at Hunter College, where there's the co-founder of the city's climate panel was also the founder of the Institute for Sustainable Cities. And first, I thought I'd bring into sharp focus the urgency about climate. This is just a recent tweet from David Wallace Wells, who writes about it at New York Magazine. So during the pandemic, emissions dropped, but actually the rate we need to drop emissions is so steep at this point that it actually has to go faster than everything that happened when our economies shut down from dealing with the pandemic. And this slide shows you a report from C40.org, which is a consortium of cities. And New York is a signatory to this group, which is funded by actually Bloomberg. And New York's commitment is the dashed line, the steepest slope. And this graph starts in 2015, so we're supposed to be heading down already. So if you look at the period between 2020 and 2030, you can see how radical the change is in the carbon emissions that we're slated to reduce. And as both Tina and earlier Dr. Zabel have pointed out, our carbon emissions are really embedded in our society. I mean, the way we use energy is what produces carbon emissions. And to change the system at the rate that we're showing on this graph basically means changing everything we do. So that's the report, deadline 2020. And I have my email on the slide and in your handout. So actually, anything that I show here, I would be happy to share links to. So one of the things that's happening is on the bureaucratic level, all of this information is well understood, on the governmental level and really at the high-end business level. So a lot of things are coming up onto the table, one of them being this seawall idea to protect New York from storm surges. And the reason I point this one out is because one way or another, the future economy is really going to be driven by climate. So we're either building giant seawalls or we're changing the energy system at an incredible rate, or both. I don't necessarily think the seawall is going to happen, but I wanted to focus on the scale here too, to get to Dr. Zabel's point. $119 billion, if you just set aside 1% of that, you'd have over $1 billion to educate people, and that might be a good investment. You might even take 0.1%. So we started with the intention of providing a public-facing explanation for these kinds of climate projections. And actually, New York City has these. We have our own climate panel, which is mostly IPCC authors. They're people who also work on the UN climate panel. And the reports get delivered to the mayor's office. They get covered in the press, but they kind of go in one ear and out the other. So we've been watching that process for 10 years now. When we started, we really focused the project on how New York could be a low carbon city in the sense of how it can be rewarding to live a sustainable lifestyle. And New York, because it's a dense city and it has mass transit, actually has the lowest per capita footprint on average of really anywhere in the US, because everywhere else you really need to drive. And there's a ton of things to do. There's mass transit. So this is how the site was designed, 4 or 5, up until about 3 years ago. And we interviewed really who's who of leaders in New York, including climate scientists like Gavin Schmidt, and these types of people that come from art, from architecture, activists, Eddie Bautista, for instance, of the New York's Environmental Justice Coalition. I would say about 5 years ago, we were working intensely on sea level. And it was really working on sea level that began to get us to pivot to focus more concretely on the steps the city needs to take. Because New York is like any coastal city, it's vulnerable. It's really facing an existential challenge with sea level, which is more or less now an inevitable process. The high estimates go above 6 feet by 2100. So once we started really focusing on that, in this interview in particular with James White, who's one of the US's leading glaciologists, is an example, we started to think about what it would actually take to run New York on renewable energy, and how you would build it, how much it would take to build, where it would go. Basically, solving climate, I think, as Tina Zuzek pointed out, you're changing the energy system. You make everything electric, and you generate the electricity without producing CO2. So there's a few things that you discover when you're figuring out how to run the city on renewable energy. One of them is that the things you see often shown, like wind turbines, are really about half the picture. The other half is the storage that you need for when the wind isn't blowing. And nobody was really explaining that. So we thought we'd do some graphics to explain it. And Ushul, actually, who's on the panel later, was working with us at this time, and she really was a pivotal person because she and I were talking, and I thought maybe making a mock game would be a good way to show it. And a moment after that, we realized if we were going to make a mock game, we should make a real game. So that's the board which Ushul designed. And you have to build 16 gigawatts of renewable or carbon-free energy to power the city. One thing you notice immediately is that the power is mostly coming from outside the city because there isn't enough room in the city, which makes it a political question also. And so we had 5 early versions. We had 5 of the first prototype. And it got onto Twitter and people started ordering it. So universities started to try it out. But we also had high school students in New York play it. And the advantage of a game in terms of understanding this is you have to make decisions while you play. And then you have to deal with the consequences of those decisions. So it takes you through both the politics and the technology, you know, both the politics and the engineering in a way that is more like real life, where you have to make choices in a condition of uncertainty, basically. Had some feedback on the game. Grist wrote us up in the last couple months. This is from yesterday or the day before yesterday, where they collected a bunch of games they liked. And this is their description of our game, which is pretty good. And these were students at The Point, which is an after-school program. They were really among the first groups that came down to our office and tried the game out with us. Somebody who's actually part of Hunters, who had gotten his master's at Hunters, was working with that group and saw us working on the game and asked if he could bring his group over, and they were awesome. They started playing, I think, in like 5 minutes. Archie and Theo, who are gonna follow me, that's Theo standing there on the right in this picture. They'll probably describe that. And then Carnegie Mellon bought 11 sets for a class on energy for developing countries, where they wanted to use the game as a way to map out the same questions. So we're really facing a crash program. I think you get that from the other speakers. But it's really like 5 crash programs. The game is showing you just the energy system, but every building in New York has to change. There's 1 million buildings in New York City. So over the next 15 years, people are going to be working on all of those buildings. We have to cut our energy use. In the game, you build 16 gigawatts, which is about 2,000 watts per person for New York. That might be half what the average in New York is now. So we're going to have to do a lot of things at the same time, and we kind of need to start today, really. So the sooner the better. And the underlying principle of this game and of communicating about the energy system is that the better people understand it, the easier it's going to be for the politics to work, because it's like a wartime effort. And so if people don't understand why it needs to happen and the types of choices that there are, it's going to be really hard, even for well-meaning politicians, to do what they need to do. The CLCPA is a great step forward. We designed the game in 2018. And one of the amazing things in the last 2 years has been to watch stuff that happens in the game start to happen in real life. And the CLCPA is something that's like that. It increased the ambition for a lot of things like offshore wind. It's still at about half the rate that you need to go. If you play the game, you can see that they're going to even need to increase the ambition again. Another thing that's not really discussed in the CLCPA is the storage to back up the wind power. And this is a huge factor. But so I can, we can talk about that later if people have questions. There's a lot of transmission lines that need to be built. The state is doing something smart in that it's changing, it's rewriting some laws, it's adjusting laws so that they'll be able to push things forward faster, because if you have to talk about each piece of infrastructure for 5 years before you build it, it won't happen. And at this point, at the end of what I'm describing, I want to just point out a couple of people that were an influence on the game that we dedicated it to. So David Mackay, who wrote really the best single book on how energy systems can change, which is called Without Hot Air. became after that the science advisor to the British Department of Energy and Climate Change. And he died a couple of years ago, but he's made a huge impression on everybody who works in this area. And just reading his book, which we've read probably 10 times, which you can read for free because it's online, it really forms the basis of how we tackled understanding the energy. And a lot of things have happened since then, but the basic, I would say the philosophy of getting things to add up comes from David Mackay. And of course, Greta Thunberg, who not only sailed to the United States, but she brought her sign. So I show that to City Atlas team people. We've had 120 interns lately. I think she's an inspiration for follow through. So now I'm going to turn it over to Archie and Theo to talk about the game more specifically.
Hey everybody, thank you for joining us, and thanks for introducing that, Richard. So I'm gonna share my screen as well, and quickly talk about how the game works a little bit, and then Theo is going to talk about how the game can be used as a teaching tool. So like Richard mentioned, Energetic is really a game about the future of New York City. So at a very basic level, the game works by asking a team of 4 to 6 players to work together to build a new zero carbon energy system for New York City, according to Paris Agreement timelines. And then recently it's been shown to kind of match up with the timelines of the CLCPA, like what Tina brought up earlier too. And the idea of the game kind of generally is to provide a thorough kind of comprehensive look at the scale, the shape, and the urgency of this transition, and to kind of concretely show everything you need to know about the energy transition all in one box. So I'm just going to walk through a few of the components of the game rather than trying to kind of explain exactly how it works, just kind of highlight some of the components that make it a really great teaching tool. And then I'm going to walk through how one turn of the game works so you get at least a small idea about the dynamics. So like I mentioned, it's a collaborative game, but there are distinct roles that each player inhabits, and these all work together. They all have different abilities and different kind of constraints. So the 4 playing roles are the activist, the politician, the entrepreneur, and the engineer. We recently added 2 special roles, the regulator, who kind of tracks and monitors the game, and then a journalist who can tell the story of the game. Because like Richard was talking about, really what the game is doing is creating a narrative for the next several decades about how New York can complete this huge project of this energy transition. So here is the board of the game, and you can kind of see the 4 roles all sit around the board and you all work together. So I'll quickly just walk through kind of the components of the board. Like you can see, the board is a map. It's slightly distorted, but it's basically a map of New York State. Like Richard mentioned, these are city-sized pieces of infrastructure that you're building in the game. To power New York City, you need to build in the rest of New York State. And so a large part of the game is kind of maintaining those community relationships. And that's kind of an indicator of the social and political constraints of the game, in addition to the technological constraints. So at the top of the board, you'll see the gigawatt tracker. Your goal is to get all the way from 0 gigawatts to 16 gigawatts. You're on a timeline, which is at the bottom. So in the high ambition version, you're trying to complete your 16 gigawatts by 2035. Along the way, you are constantly monitoring your grid stability scale, which is the orange scale on the left side of the board, and is basically a measure of whether you're keeping the lights on as you're making this transition. The grid stability is lowered by variable sources like wind, and then raised, like Richard was mentioning, by building out this storage system. Finally, on the right side of the board is the public opinion scale, which is another big constraint and determines your odds in an election. So I'm just going to walk through all the different types of cards. These are your build cards, which introduce players to the tools, the technological tools that will complete this energy transition. There's also research cards, which are blue, to unlock new types of technology. You can pass policies with these gray policy cards, conduct community campaigns or raise money. And finally, here is the unit of money in the game, which is the energy buck. And like everything in the game, it's tied to reality. 100 energy bucks equals $1 billion of real life investment. And then finally, there's also an element of randomness and uncertainty in the game that comes from these random event cards, which your team has to overcome 1 or 2 every year. And these are mainly climate impacts, things like natural disasters, and then also social and political climate impacts. So I'm just going to walk through one turn really quickly. So the team collects your annual budget, which you all work together to decide how to spend. Every player draws cards. You all discuss, you decide, you make a plan for the year, what you're going to do with those cards. Each player can play up to 2 cards, and you go around in order. And then you experience your random event. If you roll a 1 to a 4, you only have to do 1. These are mainly unpleasant events since they're climate impacts. If it's a 5 or 6, you do 2. And then finally, if it's every 4 years, then you complete an election. And if you lose the election, your budget's cut in half. And then you move on to the next year. Very recently, we've made a beta version of the physical energetic, and it is available on through Steam. If you have questions about this, please email us. Right now, you have to download another piece of software to access it, but we're hoping to have it independent soon. And here are just some stills that kind of show how the game is played online. So now I'm going to pass it over to Theo, who will talk about how the game is used as a teaching tool.
Yeah, hey everyone, super happy to be here. I'll try to go quick because I feel like we may be going over our portion of time. So yeah, as Richard talked about, as about January of last year, we started bringing the game outside of the office for the first time and really playing it with groups of young people. To answer a Q&A question, we brought it to many groups of adults. Those were actually kind of the first players of the game, were adults and many kind of energy scientist types and policy people. And so we were very sure about kind of, the dynamics of the game, that it was super accurate. We didn't know as much about, how engaging it would be, how fun it would be. And we actually realized really quickly and over again that people really loved it and really enjoyed it. And so this is a few pictures of us teaching the game. This is the event at Carnegie Mellon where we had, I think, 12 games going at once. It was a little overwhelming, but quite exciting. And through all these experiences, we've learned many things. First, it's really engaging, fun, and stimulating. As Archie showed, there's a lot going on in the game. From our experience, young people really love this and are kind of drawn to the challenge of trying to understand everything that's going on. And learning about climate change can be both scary, overwhelming, and also can get, as like the demonstration with the trillion versus a billion, it can be hard to kind of fathom this stuff. So I think there's enough here that people can really engage with it, but also without sacrificing kind of the reality of the science. It allows young people to become comfortable with critical technologies, concepts, and industries, which will define the future of New York City. As Tina talked about in the beginning with the CLCPA, there are billions, if not trillions of dollars worth of major energy infrastructure going to be built throughout New York over the next many decades, and beginning right now. You know, many of these contracts have already been awarded. And so for young people thinking about where to kind of find a career, we really think that exposing them to these industries early on and in this type of engaging way can be really effective and quite powerful for them moving forward. It also provides concrete options to address climate change at a systemic level. You know, young people are so worried about climate, and increasingly so. We think that from our experience, you know, me and Archie in college, you know, we learned a lot about the challenges and the problems and the impacts that we're going to cause. We learned less about what it actually takes to solve it at a systemic level. Energetic begins to do that. And that finally, it empowers young people to come up with the solutions themselves, rather than just kind of telling them the various pathways to decarbonize New York City. You know, it's kind of cool to watch them try to grapple with them themselves and to collaborate and to talk about it. And even in just playing one session of the game, by playing this collaborative board game and having to talk through all these decisions, you inherently become familiar with concepts that are really rare for the average, even adult to know about, even a policy, you know, wonk to know about. And so it's, it can be a real advantage. And so as we've also, you know, begun to realize the educational potential that Energetic has, we've now started to design some educational materials to kind of supplement what Energetic shows you. So this is a graphic representation we made showing a turbine compared to the size of Manhattan skyline. So though the actual, you know, turbines wouldn't actually go here, this is just to get a sense of the size. Each is 180 feet tall. This is then, on the left, is Manhattan versus the size of one piece in Energetic. When you play one wind turbine piece, that's a gigawatt of wind. What it actually is 167 of these giant wind turbines you see right here. And so we've now, you know, trying to, and then this is what it would look like if you had 16 gigawatts, which is what you need to power just New York City in renewable energy. This is what it would look like if you had 16 gigawatts of just offshore wind off the southern shore of Long Island. So we've made kind of materials like, we're beginning to make materials like this. And then we've also begun making this guide that explains everything in the game, where we're getting it from, what it means, and real life examples to make it more real and to help educators also. So, you know, basic things like what is energy, what is power, why are we going towards 16 gigawatts, what's a power grid, to more technical things like what is pumped hydro. And then we have the same thing for each of the random events that are in the game, which cover, you know, health impacts, political events, and extreme weather events as well. So I'll stop there. Sorry if that went on a little long. Please, I'll stop sharing. Our email and contact information are included in the bios that you all received. And please let us know if you have any questions. We'd love to talk more. Thank you.
Thank you so much to the City Atlas team for explaining the game for everyone. As in the bios, you can certainly chat with them more and talk to them more about the game and as well as order it from them. Okay, so I'm going to share my screen so you can have some visuals. Okay, so as we mentioned, Engineered Green Economics is a part of the WISE Institute, and we are able to bring a lot of different types of youth development, hybrid educational programs to teachers. And so this is just one picture of our team or volunteers coming in and working with students and talking to students about materials. So the big question is tomorrow's workforce really prepared for climate action? And what does that really mean? And right now, the students really aren't completely prepared, but we can give them an edge. I'll never get over using that, that pun. So the EDGE program really prepares the students for this complex world that we're embarking on. And right now, the way we're going about dealing with climate change is sort of individual behaviors and some changes by companies and government. But if we're going to really address climate change and water pollution and water shortage, social injustice, we really have to have an integrated, comprehensive approach to it. And that means system change. Systems change. And so how can we really make that happen? And that is really through the productivity of labor, because we spend half of our waking hours working, and laborers are what drives the world. I mean, think of the Industrial Revolution, and that has made the biggest impact on us. And the only way we can reverse that is to have a new type of revolution, and a very sustainable and peaceful one. So sustainability education is part of that solution, and this is how we are able to bring it to you. And so I know we've talked about a lot of creative things, but right now I'm going to ask you to put on your logistical hat. So with EDGE, what we do is we try to incorporate sustainable development goals, but in a way that makes sense. So into these three pods, the social aspect, the economic aspect, and the environmental aspect, so that we can really merge all the disciplines and really start to work towards that comprehensive approach. So how do we do that? Well, thankfully, we have this wonderful, amazing advisory committee. Some of them are highlighted today. I usually try to highlight the work of our advisory committee every year at our conference. And so you see some of those names here. And what they have helped us do is to really identify the major issues so that we can transition our students to higher learning and to careers that incorporate sustainability. So right now, some of the issues that we're dealing with is, of course, climate change, but there's also material waste, resource depletion, and inequities. And we sort of identified those as the major problems that we're going to deal with at this first phase of this introduction to sustainability and our EDGE program. And in that, all those things, there's human impact and the carbon footprint, which has been spoken about in the last two speakers, And the way the human activities that impact that create those problems is really our usage of energy, our mobility and transportation, our materials that we use, our manufacturing and all of our consumer goods, the food that we consume, and our buildings and efficiency. And those are, in fact, what we cover in our introduction to sustainability. So that gives students the groundwork for an understanding of the major areas of sustainability. And then we follow that up by case studies, and that is delving a little bit more deeply into to look at how firms are actually dealing with each one of these problems and addressing them. As a signature program of the WISE Institute, what we do is we bring in experts. Just like today you hear from our experts, you will have experts in your classrooms as well, experts and scientists. And they will be able to talk about these issues in an in-depth way, but also bring their experience from the industry and talk about the breakthroughs in the industry that you may not be able to have really in the textbooks or relatively easily at your fingertips. And of course, we provide professional development. So EDGE really sort of tries to incorporate the environmental. We certainly have a lot of scientists aboard with us so that we incorporate a lot of STEM, but we certainly do not shy away from talking about social and economic issues. And that to us incorporates what sustainability can be, how sustainability can be taught to students. So you might be wondering if we offer our programs virtually. We do. We do 45 to 60 minute live instruction. We've been doing it since the changeover because of the pandemic. And we work with all of our presenters, our experts, to be able to provide those seminars to you with live instruction at a level that is appropriate for students. And of course, we also do in class, when we get back to that, we do in class, we do different types of, we have a lot of different flexible models so that we can really serve all of our schools. The person who's in the front of the classroom on the left is actually an alumnus. He teaches about sustainability now. He's actually teaching this afternoon at one of the classes at one of the schools today. So we really would be thrilled to talk to you and figure out ways in which we can bring sustainability education to your school and to your students. So what has been the impact of this? So again, we don't want our students to think that sustainability is really just siloed. It's just about the environment. We want them to begin to understand that it is a comprehensive issue and we have to deal with it that way. So in our pre and post test, we see that 89% have the idea that it should be something that's integrated together. But after the first 8 weeks, 95% think that it is an integrated issue, that it's not just one-sided. And here, after just 8 weeks, you see how much more students are interested in science, engineering, and mathematics. The quote here is basically that many companies are looking for employees that understand environmental, social, and governance issues. Governance issues will cover things like diversity or health and safety in the workplace. So they want employees who understand these aspects, and therefore we can train our students, we can expose our students to these issues early so that they can continue and transition into college with these concepts and be able to study it further and incorporate that in their career. And of course, that means that it's beneficial for all of us and our planet. So these are some of the things that students and teachers have said in the classroom. I think my favorite one is the one that is right here. It says, I recommend this seminar. And he's talking about the students. Let them experience what other careers there are to help the planet and our community. And I think that's really appropriate. It's what we are hoping for. We bring, again, a lot of different industries into the classroom, even just in 1 8-week period. And that is how we're able to encourage our students to pursue sustainability in their personal life and in the future. And I think, let's see, I'm just looking at the questions here. So we are planning to have more schools. I know there are some elementary schools in the audience, so I just wanted to and these are some questions that were submitted ahead of time in the Eventbrite. Just wanted to address them really quickly before we go to our panel. That's who has been waiting for us right now. So what are some ways to interest younger students? And I would say art. Art is huge. I think that as students learn something and they draw it, or they create 3D art from it, or they reuse materials to create art. Young people that young, they're so good at teaching their own parents about the things that they're involved in. Parents are very tuned in to their young children. So if kids are creating art about sustainability, you know, that's a really great way to teach up the generations. Biomimicry is really great. If you want to, you can email me. I can send you some links to biomimicry lessons, but that's really fun. I also wanted to plug Ingrid's, the Paleontological Research Institute. They have some great videos. I mean, some of the videos is just like, you know, looking at leaves and how they change over time, over the season. And those are really great because you can do that really in your neighborhood as well. Last year we had a presenter who talked about collaborative math, and that's basically, if you think about Hidden Figures, where they had the different specialists in their mathematics team. And you can do that too as a lesson, and you can rotate the specialists. So you can, if it's a question, if it's a, one of those word problems, you can have the student sort of set up what the problem is, and then another student solves them. If it's PEMDAS, you can have, you know, they can decide which team goes first, or and that type of thing. So those are some ideas that I've seen done. And then in terms of, we talked about a lot about what employers are looking for, and when that is all different from different industries. And so when we have our volunteers come in from the different industries, then it becomes much more specific. I think we had one time students asking, you know, what should I choose, this career or that career? And the presenter didn't give a straight answer, but gave them the pros and cons of each. So those are the, so that really helps to engage the students in thinking about their future. And the last is that, you know, is there a meaningful, you know, way to address all these things, because it all seems depressing and overwhelming. I hope that after today you won't feel as if it's so depressing and overwhelming. And I feel as if we asked the students this as well in one of our seminars, and they said it's not depressing, because they feel as if there's innovations on the horizon that will solve the problems. And so therefore, you know, they're very optimistic about, they're very optimistic about what we can do to solve some of the many problems that we have on our deck today. So that was very quickly how EDGE can help you in your school, and we look forward to continuing the conversation with you. But I'm going to turn it over now to our panel, and to introduce the panel will be our WISE board chair, James Abry. He's volunteered with WISE for 25 years. And yes, he began in the classroom. He was one of our volunteers. And after 25 years, we expanded his responsibilities, and now he's chairman of the board. Jim.
Thanks, Kristy, I appreciate it. I'm Jim Abry, and I'm honored to serve as the chair of the board of WISE. It's the mission of WISE to support young people to fulfill their potential through financial literacy, education, and readiness for college and careers. And we're really pleased that WISE continues to provide cutting-edge, award-winning programs that are truly relevant and meet the needs of students. Our work to advance sustainability education is a perfect example of that. It's something we firmly believe in, and I think we all should, with so much at stake as we've heard today. It cuts across a wide variety of disciplines: science, technology, business, investing, architecture, design, social equity issues, government, and public policy. So it can resonate with students across many levels of their interest. And with your help, we can find an accessible and promising path for them to pursue their passion. I'm really looking forward to today's panel. It's my pleasure to introduce Mr. Harun Assad, who you've heard about, a wonderful supporter and advisor to this program since its inception. And he is the head of sustainability at Edison. He'll be our moderator for today's panel of experts. The subject is A World in Crisis, from COVID-19 to Climate Change, a look at tomorrow's workers. Please give a warm welcome to Harun Assad.
Good morning, everyone. It's a pleasure to be here. This is the second time we've done this, the first time being in a live environment, so this is certainly a little bit different than the last time we did it, but we also have the benefit with technology of being able to include a lot more people as well, including some of you from overseas, I believe. So that's very exciting. It's exciting to see the growth of the program as well, and continued interest from lots of different stakeholders and parties. So again, it's a real pleasure for me to be involved with the organization and with this sustainability education program. And the game that we just saw, I think is really, really cool. I'm excited to see that get rolled out further. So those are my introductory comments. A little bit about me. As was mentioned by Jim, I'm the head of sustainability for Edison. For those who may not be familiar with Edison, it's one of the largest investor-owned utilities in the United States. We're actually a holding company. There's a regulated utility side. There's also an unregulated side that can operate in all of the states across the country. And it's through that unregulated side that we are the second largest solar producer in North America and the 7th largest in the world. So we obviously have a keen interest in the transition to a low carbon, clean energy future. Edison, historically, as a 200-year-old company, has had a long tradition of leadership and commitment to not only the environmental aspects of sustainability, but also the social aspects of sustainability, whether that's diversity and inclusion or community impact and talent management, engaging with customers and partners. And obviously right now we're seeing a lot of the social side of sustainability come to the forefront recently. I'm going to give a quick nod to our 4 panelists. And by the way, for any of the panelists, if you have some time constraints that we need to be aware of, if you could just indicate that to Kristy, and then she can text me about it in the chat, or she can manage it herself by jumping in as needed. I'm going to hand the baton to each one of you to briefly introduce yourselves, and then we'll get into some of the Q&A with the panelists. So first off, let's go with Mark Chambers. Just a real brief introduction, a couple of minutes, Mark, and then hand it off to David.
Sure, thank you, and it's kind of thank you to all for joining and having me here today. So fairly quickly, my name is Mark Chambers. For the last 3 or so years, I've been the Director of Sustainability for New York City. And so for the mayor's office and for your great American sanctuary city that is New York. And I think it's important to remember as we start thinking about a lot of the complexities between the social and the environmental components of sustainability. A lot of those are coming to the forefront in a way now that is much more tangible for people. And that's a very consequential time for us to be working. So as Chief Sustainability Officer, it's my responsibility to paint a really clear picture for all of you around what our city needs to be and where our city needs to be in the next 5 years, 10 years, 50 years in terms of our relationship to our home planet. And it's also incumbent upon me to really draw a bright line with policies and programs and staffing and skill sets to look at how we, at each point along that course, look to decarbonize the systems by which we live. And those are energy systems, transportation systems, financial systems, food systems, everything, even cultural systems that allow for us to kind of look at the physical and social infrastructure that underpins all of those. And simultaneously to be able to look at how we tackle climate while simultaneously tackling inequality. I think those are the really underpinning components of why it's so important to be doing this work right now. Like a lot of you, I come to this for both a sense of community, but also to contribute and to find a better way forward for us to be able to, be a part of this fight as part of our shared human family. And I think one point I want to make is that I'm an architect by trade. That's my background. And so I often looked at things from the lens of how do you three-dimensionally problem solve and how do you unpack the built environment to solve for a lot of these problems. But I also come to this work as a parent and as a partner and as a public servant. And I think it's important because we are in a time now where there's no room on the sidelines anymore for people to be able to be investing in this fight against climate change. So it's imperative that no matter what your skill set is, no matter where you're coming from, no matter who you are, what you look like, who you love, what your passions are, we need those to be directed towards fighting climate change, point blank. Like it is something that everyone is going to have to bend their skills and passions towards. And so part of my job is to be able to help create that narrative, create that imperative, and to also kind of drive the city forward, not just within the 5 boroughs, but also as an example for what other cities can do to unlock their potential, both nationally and globally. So again, thank you for having me here, and we're excited to kind of engage and be as thoughtful partners with everyone as we can and stewards of this work going forward.
Hi. Thanks, Mark. So my name is Isil. I'm a designer at an architecture and urban design firm called Cooper Robertson and Partners. But also I'm working with several nonprofits on climate change advocacy, education, and also urban resilience. So my training is also in architecture. I have a Bachelor of Architecture from Istanbul, Turkey, where I am from. And I've been in New York since almost 3 years now. And I'm one of the designers of the energetic game that you saw. So when I was in my graduate school, I started interning with City Atlas, and that turned into a long-term commitment into this beautiful educational tool and board game that we created all together. And I'm really grateful that they are continuing to take it further even. And so aside from my day job, I also work with the Ready Center, Resilience Education, Training, and Innovation, based in Red Hook, Brooklyn, on their community resilience initiatives. And I really liked what Mark said about bending tools and identity towards climate action. And I think that really spoke to me when I decided to be involved more in educational initiatives, aside from my architecture and designer kind of job. And I've been doing that ever since. And I'm really excited to be here as well and continue that work with WISE Institutes and City Atlas and Ready Center and several other not-for-profits that really fill in the blanks in this industry, leading towards climate action. And with that, I think give it to David Davenport to introduce himself.
Good morning. It's a great pleasure to be here with you today. My name is David Davenport. I am a Senior Vice President at Urban American Management, which is a large owner and operator of multifamily real estate in New York City, and the principal of an in-house energy service company, Resco, that focuses on retrofitting very large multifamily buildings. And I look at my career and say it's kind of from the boardroom to the boiler room and back. For over a decade, I was an investment banker working in community development, investing in urban areas around the country, in private equity investments, and in manufacturing that create jobs in urban areas, and also investments in real estate, investing in affordable housing and mixed-use housing in urban areas. For the past 10 years, I kind of built on that experience and left the financial world and went to work in the space with many of the private equity real estate companies that I'd invested in, working with them on their urban assets, in this case, New York City, on financing and developing and operating deep energy retrofits on multifamily buildings in New York City. So I've done, gosh, probably over 10,000 units of energy retrofits on multifamily buildings in New York City. And my goal and my joy as a professional is solving the financial puzzle and figuring out what the risks are out there and doing this work and figuring out ways of mitigating the risk. How to demonstrate that energy retrofits in big buildings, reducing the energy intensity and creating energy on site, are good business and investments. Learn the economics of the retrofits, learn the building science, and apply it in replicable ways that can make a market. Today, at the right time, I'll talk a little bit about a teachable vision of the field of energy efficiency, particularly as it relates to students of color, to position them for jobs of the future. Thank you.
Hi. So I am, I think I might be the only panelist who's not in New York City, but I lived in New York City for almost a decade. And I also taught high school for a few years, so I've spent some time in the classroom. My name is Peter Kelmis, and I am a climate scientist at NASA's Jet Propulsion Laboratory. I'm speaking on my own behalf. And I've also been a climate activist for the last decade and a half. I can't look at the science and not be an activist. I've got two kids. They're going into 7th and 9th grade respectively. And it's unclear to me how anyone can spend all the time looking at this data and what's happening to the Earth system and the future that our children are facing without just doing everything they can as an activist as well. So I have had a long path to become a climate scientist. I started out in astrophysics. I got my PhD at Columbia in 2008. And, you know, every year as an astrophysicist, I became more concerned about climate change, or call it climate breakdown, as I call it, because everything's breaking down and it affects our economic and our agricultural and our water systems, our education systems, energy systems, of course. And so eventually I had to make a shift in my career, which scientists don't do that often. And so I became an earth scientist. And now I'm shifting again into biodiversity because I'm very concerned about what's happening to the planet's ecosystems. So one of my projects is making projections on coral reef health and lack of health, so bleaching and mortality out toward the end of the century. because as I'm sure you know, the oceans are getting hotter and hotter and hotter, and that's going to continue so long as we burn any fossil fuel whatsoever, and that extra heat is killing the corals. So part of my path also was writing a book called Being the Change, where I kind of looked at how we can respond to this overwhelming crisis and how we actually need change at all scale, from international down to our own lives. So I don't have time to go into all the activism that I've done. I wanted to say that the energetic game looks amazing. City Atlas clearly knows how to make games, and they might want to also consider a game that addresses the interesting and complex world of demand reduction. I know Richard mentioned that when you win energetic, you're only building out half the electricity that we currently use. And if we can reduce our demand by a factor of 2, you only have to build a quarter as much, this is US nationally, a quarter as much renewable and a quarter as much storage. So I also want to say that this is absolutely an emergency. This is a life or death thing. I was kind of asked sort of not to say that really, but I don't see people responding like this is an emergency. And I don't think that the public really understands what an emergency it is. I think it's probably pretty clear to everyone that transforming New York City is not enough. This is a global problem. It'll be very helpful to have cities that are beacons on the hill that sort of show the world how to move forward with this. So symbolically, that's incredibly important. But the carbon that we're emitting is a global problem. We've been emitting about 2% per year more every year than the previous year for the last 200 plus years. The 17% reduction at the peak from the pandemic, that basically resets us back to 2010 for like a few days. And now we've already almost gotten completely away from that reduction. And we have to be reducing year after year after year. So it wasn't nearly enough. What we really need is a global movement. And the global movement started to take off about a year and a half ago, and it was led by students. Students were a huge part of that. And I think we need everyone to be part of that movement. And I think teachers play a critical role. And it's unclear to me, why there hasn't been a fierce teachers movement in support of these students, because their futures are going to be utterly transformed by this. And the curriculum, as we've been teaching it historically, isn't preparing them. And it's going to, the future that curriculum suggests for them is going to be that suggested future is radically different from the future that they're actually going to experience. Thank you. So I'll pass it back to Harun.
Okay. Thank you to all of our esteemed panelists for joining today. I appreciate your participation as well as your deep expertise. Let me start where we kind of left off, actually, if I may, with Peter. Personally, I come from a business background. I do some teaching in sustainability at New York University from the broad lens of sustainability. A number of our teachers in the audience may not come from a science background as well. It would be great if you could take just a couple of minutes to clarify in lay terms a little bit more about what climate activism actually means, as well as some of the ecological forecasting that you do at NASA.
Well, so ecological forecasting so we have global climate models, right, which sort of model the entire planet. They model the ocean, the ice, the atmosphere. They divide up the planet into little grid cells that can talk to each other as, air, for example, moves from one to the other and moisture moves from one grid cell to the other. And so we can use these models to make projections into the future of, things like temperature, surface temperature, things like precipitation, things like sea surface temperature and how the oceans are going to change. But those kind of fundamental physical variables are, of course, very, an ecosystem, a forest, for example, cares very much about how hot it is and how much rain there is. A coral reef is the same way. It cares very much about how acidic the ocean is and how hot the ocean is, especially. So ecological forecasting basically, at least in my project, and there's various forms of it, takes those projections from the global climate model and tries to apply them to these specific ecosystems. So, you know, after a coral reef gets to a certain, after the ocean heat waves get to a certain intensity and frequency, the coral reef can no longer thrive. And then after it gets to even a hotter level, the coral reef's going to start bleaching. After it gets to an even hotter level, the coral reef's not going to survive anymore. And, you know, we've seen the planet get warmer. I could show you all kinds of plots of just everything's going up like this. You know, surface temperatures going up, ocean heat's going up. Ice sheets are going down like that. Sea level rise is going up like this. We're not entering a new normal. What we're in the midst of is this kind of, this ramp that is physically inevitable. And it's also irreversible, essentially. So the only way we can reverse climate breakdown and global heating would be to actually suck the CO2 out of the air, which we don't know how to do. We certainly don't know how to do it at scale. And it would be incredibly expensive. It would have to be on a similar scale as to our fossil fuel infrastructure is right now. And so it's, you know, I don't think it's plausible to count on it and to saddle our kids with the economic cost of doing that, which is kind of what we're saying. We're saying if you know, we do a bad job reducing our emissions, then 30 years from now, you know, people can build this massive system of pulling CO2 out of the atmosphere, which is like running the economy in reverse, right? Because our whole economy is powered by burning this stuff, right? So to take it back in, it's like running the economy in reverse. So at the same time that, and 30 years from now, that's our kids, right? So at the same time, they're dealing with all of these increasing hurricanes, increasing floods, you know, crop failures, wildfires in the West, geopolitical destabilization. We're effectively asking them at the same time to build this mass. So the point, it's basically irreversible, and we have to reduce our emissions as quickly as we can, and then we'll stay at the temperature that we're at right now. So that's the kind of the ecological forecasting and science part of it in a nutshell.
Great. Thank you. Let me bring leveraging what you just talked about from kind of like a macro or global perspective. Let me bring that back to our local geography and ask Mark if you could react to that in particular to speak about, I know there's going to be some changes administratively where you are and how in light of those potential changes, how the city is going to continue to be committed to environmental and social impacts in the context of what some of the things Peter just talked about.
Sure, and I think the one thing that Peter kind of hit the nail on the head, I think early in, is this notion of activism, and the fact that, and something I said also, is that there's no room on the sidelines, right? So everyone, if you're not an activist, if you are not fundamentally kind of pushing yourself in this direction, then you are not doing enough. And so it is something in which we do have to change our methodology a little bit to move away from status quo being okay. If I'm not hurting things, then it's fine. That's not the case. We all have to become activists. And I think when we think about administrations and the changing times, so this administration here, the mayoral administration in New York City, there's about 18 months left. So it goes to the end of 2021. That's not the only administration that's going to be changing, right? So there's the administration that will be changing potentially in November, hopefully, is one in which we have the potential to look at what national leadership can look like where it comes to combating climate crisis. And the reason that's important is because no matter what we do as cities, and largest city in the country, we have very ambitious goals. We've committed and set things into statutes and legislation over the last year that have never been done before around the city's commitment to decarbonize our building stock. We passed laws to be the first global city to be able to actually put a cap on emissions that buildings can be responsible for, large buildings going into effect over the next few years. And if you're over that cap, you'll be fined. So setting a tone of what the real cost of carbon is. But no matter what we do, it is no substitute for aggressive federal action. Like what's necessary in terms of galvanizing and giving cities the tools for that their laws can actually do more than just maintain the status quo is for large-scale federal mobilization around this being the emergency that it is. So when we do kind of pass laws and we've been codifying our energy codes to make them more stringent, so forth, and that keeps going. We will continue to do that work. But right now, I think what we're seeing across the board is that it takes more than just us as either professionals, academics, politicians, or those in different or the design community or so forth to be pushing the envelope. It actually takes a movement and takes a large-scale effort that is a little bit more grassroots than that. And so I'm excited to kind of figure out how do we bend those things where it's not just the laws that we're doing, but it's also these are the same things that are driving people to kind of demand more and demand us to have those wholesale changes in our society.
Mark, is the goal for the city to have 80% reduction in greenhouse gas emissions by 2050, is that still valid, or has that moved in light of the Climate Leadership Protection?
Right. So both in terms of the Climate Leadership Protection Act as well as the kind of local New York City acts that were passed last year, it's moved towards a carbon neutrality goal. So instead of just 80% reduction by 2050, now there's a carbon neutrality goal by 2050. Of course, so many pieces need to happen in order to make that happen. But one of the key pieces is increasing the availability of transmission into the city. Most people don't understand that New York City is not really in control of our energy systems in that kind of way. So we do need there to be significant transmission so that new development of renewables, whether upstate, offshore, can actually, have an extension cord that connects it into the city so we can benefit from that.
Sure. David, let me turn to you in the context that we're talking a little bit about legislation. If you could talk a little bit about Local Law 97, which has an impact, of course, on buildings. So I'm sure you're feeling some of the impact of that in your line of work, and how you are, first of all, briefly explain what Local Law 97 is all about, and then how you in your business and working with some of your customers are dealing with that.
Sure. Well, Local Law 97 is one of a number of laws that the city has passed to encourage building owners to reduce carbon emissions in city buildings and make buildings more efficient. It is an outgrowth of things like Local Law 84 and Local Law 87, which have required benchmarking of buildings. Basically, that required providing a snapshot of what your carbon output has been. And then through various initiatives and incentive programs encouraging you to make investments in efficiency and on-site power. What 97 is going to do is give buildings a grade. It's going to give buildings a grade based on their energy footprint and encourage them to get better grades and also really require a certain level and standard of energy efficiency in each building. So, in the world that I work in, which is really working with real estate firms, people like talking about energy efficiency. People like talking about sustainability. For new construction, people talk about LEED and these things. Well, Plato had this concept of, the perfect chair. and every day we're striving as we build chairs to make the perfect chair. And it's the same thing with LEED in buildings. If you can have a perfectly efficient and sustainable building, what does that look like? And you have these various programs that provide grades. There's lots of grading of building, whether it's by the city or by the state or by Energy Star or by LEED. on how efficient it is and how well it's designed and these things. But building owners are primarily driven, if they're not new buildings, and you can build a new building to the most current design standards. You know, my clients are focused on how can I get the biggest bang for my buck for each dollar spent, okay? And ideally with incentives from the city and state, and I've worked with Con Edison to get some very good incentives. You know, how can I get the largest return on my investment of capital by investing it in sustainability, on-site power, renewable energy, and energy efficiency.
Right. Isil, if I could turn to you on that topic from an urban design perspective, if you could share with us, how do you try to help some of your customers maximize their environmental and social, meaning community impact, when you're kind of upstream from an architecture perspective, trying to plan out what may be built?
I think this is a great transition because what everyone mentioned about sort of these local laws is really what drives most of the projects, right? Architects and designers have a role to influence their clients, but we are really not decision makers in the sense that we can just create the best building, the optimal setting as we want it to. And I think that it's really important for architects and designers and urban designers to understand that advocacy is really a big part of our work, because we are bound by the policy that drives the local decisions, and you know that the code, the building, basically, and everything else that was just a second. The building code and then the certification programs and all these local laws, they just really drive the decision making. And I agree about the biggest bang for the buck. I think this is the biggest challenge for any designer, to convince the client to do better. And I think our only leverage is really these laws. And I think in New York City, we have a lot of them that help us. But in many other situations, I think it's even harder to get that out there. But I want to touch on the community side of things, community initiatives. For example, a lot of communities are really working on creating microgrids for themselves. And I think that's where the additional community agency comes in play. And because climate crisis is also a social justice issue, an environmental justice issue, a lot of communities realize more and more that they have to take their fate into their own hands. And from an urban design perspective, I also want to say that, professionals in the urban design and architecture world really started to understand more and more that the individual projects in the architecture or urban design profession can't really survive in a vacuum. So where there are pandemics and climate crisis and any other crisis that is exacerbated by the climate crisis, which is the case. And add to that the social and economic injustice that is constantly plaguing the urban areas that we live in. So it's really hard for designers to separate ourselves from these existing conditions and think about our projects in a vacuum. And I think we are just understanding more and more this is a systems problem, and architects and urban designers' role is not just working on our individual projects, but really working on advocacy and advocating for the right, using the tools that we have. I think that's
Mark,
really...
I'm glad you kind of brought forward the social issues. So Mark, I'm curious, from the city's perspective, what are some of the key social issues, not only today, but say over the next 5, 10 years, the city is focused on?
Sure. So, I mean, again, Isil kind of hit the nail there, where it's like the interconnection between multiple crises occurring at the same time is unavoidable now. You know, let's say, for example, we're moving into the summer in New York City, and we're confronting not just the pandemic, but we're also confronting what will likely be an extreme heat condition throughout the summer. Extreme heat is one of the, if not the most kind of deadliest components of current experiences related to climate change. In New York City, it kills over 100 people each summer. And we have to be able to kind of look at the impacts that are happening right now, as well as planning for the future. So a lot of our work in the climate space is not just around mitigating future greenhouse gas emissions, future carbon, but also looking at how do we deal right now with adapting to hotter summers. We have launched a program this summer, which is actually assisting especially most vulnerable older New Yorkers with having access to air conditioning in some way, knowing that they won't be able to go to congregate settings like cooling centers or libraries and community centers. So being able to look at the intersection between some of the cultural and social needs, as well as those that are particularly environmental and particularly climate related. And I can't stress this enough about the point of activism, is that we keep seeing this larger kind of culture of empathy that is emerging, and something that is a response to general social contracts, I think, being broken, particularly for younger people. And so as we start to be able to move in a place where, from a city perspective, we are kind of supporting and doing everything we can do to set laws like Local 97 and so forth in motion, and draft them and get them passed and do all that work. We also need to be able to, I think, nurture and get out of the way of a lot of the elevating voices of those that are frontline communities that are truly experiencing the most impacts of climate change, and using our platforms to be able to elevate those voices and do that in a way that allows for more people to understand the impacts that are happening to them, happening to their communities, and then giving them ability to really kind of suggest and push for policies, initiatives, or new ways to be able to adapt quickly, and also change some of the behaviors that will ultimately stop impacting them so greatly.
Absolutely. David, in your line of work, I'm curious if the conversations are primarily about the environmental and ROI aspects you mentioned, or to what extent, if at all, do these kinds of social issues, or perhaps affordability being another social issue, factor into the purchasing decisions by your customers?
No, that's a very good question. The owners that I work with own existing housing stock. They've been in the affordable housing business, and they have limited resources. So one of the key focuses, in addition to driving down the cost of the energy, is also and doing some renewable energy on site, is getting to the culture and the lifestyles of the residents in the buildings that have an impact on the results of projects. So just to give you an example, my retrofits typically involve projects that include building envelope work, making sure the building is airtight. Your most expensive systems are your heating system and your cooling system. And how do you make the building more efficient with the systems? Well, you really make it as tight as possible with windows and closing penetrations, so that the impact of and cost of energy used in heating and cooling these spaces is less. Now, in many cases, the control of heating and cooling is in the resident apartment. So one of the social issues in a successful energy retrofit is being able to work with the residents, and I work with multifamily buildings, so imagine lots of apartments, working with the residents to get them to change behavior on how they use heat and cool, and or put technology in the apartments that allow for remote control, a little less resident control and a little more owner and building manager control of the heat and cool. So maybe now you're not heating your apartment as you used to 80 degrees, but because we put in new windows and made the apartment more airtight, you don't need to heat it to 80 degrees. That's an efficiency play. Now it only has to get to 72 degrees for you to feel as warm, and we cap the temperature there. So these are some of the functional ways that the technology and the types of measures that go into buildings both meet with resident engagement and resident behavior. And the way you have to strategically explain these things to residents, because there's a whole psychology of making the energy retrofits work. You know, the impact of the project will in addition to being a function of the equipment that's installed and how well it's installed, it'll be a function of how well the occupants adopt to it. So occupants that are going to work with you and not sabotage or work against the measures that you put in, that's very important. And it's important to get buy-in from the occupants, and this is where resident education is important, and helping residents understand that as the cost of operating the buildings come down with the reduced energy use, that decreases things like the need to increase rent. So you have to show a win-win value proposition to multiple parties to get these things to work.
That's very insightful. Thank you for sharing that. I want to switch gears. I'm going to kind of head towards wrapping up the session so that we have a little bit of time left for Kristy and Phyllis to kind of close things out. Two more themes I'd like to address. One is any thoughts and guidance related to career choices for students, as well as your suggestions for their students. And then second theme is on the UN Sustainable Development Goals. I'd like to kind of insert that here. So I'll do that starting with Mark. But first, to the career line of questioning, Isil, if we can start with you. Do you have any thoughts or guidance for students and teachers in terms of, based on everything we've been talking about, all these various issues with sustainability, some potential career pathways that might be opening up in your line of work in the future?
Sure. So I absolutely think that there will be some concrete, like bread and butter, lots of work happening around building retrofits. So of course, all the trades, that's something that absolutely has to happen in terms of buildings moving towards being electrified, and all of the interconnected systems, energy systems that go along with that. That work is going to be critical. But I want to stress the notion of the interdisciplinary work that's also going to be required. It's not so much that we have to take the notion of people moving into professions that will be just in demand as it relates to combating the climate crisis. We have to think about bending all professions towards doing this. So we have to be thinking about the fact that we need those that want to get into finance to come up with better financial tools, so that we can, so as David was saying, so we have better options for building owners that want to package retrofits and package different things that meet their ROIs, but also allow for more creative options for owners that might not have upfront capital. We need, those that are in the arts to better disaggregate and unpack the work around climate response in a way that makes it more digestible and makes it more activating for the larger population to be able to be engaged. So it's not something where you need to move and people need to be moving so quickly into a profession that will just be in demand, as opposed to making sure that we recognize it's all hands on deck. So those that are in academia, whether it's like K through 12 education or higher learning, all of those need to fundamentally be making sure that you're equipping all disciplines to be able to be responsive to the climate crisis. Otherwise, everything that Peter talked about before from the standpoint of the larger kind of global epidemic, that we're dealing with, not so much COVID, but more so climate, we're not going to be able to galvanize the responses necessary. What we saw over these last few months is how much has changed, and also how far we have to go around responding to climate, and the ability for our changes to impact the numbers. It's gonna need everyone on deck, and no matter what it is that you're focused on in your kind of personal passions or pursuits for your professional life, it has to be focused on climate and towards it.
Taking a kind of interdisciplinary point of view from an education and career perspective, I think an excellent takeaway. And in fact, from my lens, being part-time in academia, I'm seeing that, for instance, at New York University, as well as Penn State University and other universities, that they are embedding sustainability education into existing disciplines. In some cases, there are separate fields of study. You can get degrees in sustainability, but in a lot of cases, it's just being embedded across the entire university curriculum. Isil, your thoughts?
So a little bit about how I came to work on climate change more and more is that I worked as an architect in Turkey for years before I realized that I was not doing enough as an architect to do my part, like in action against climate change. And it wasn't even close enough with the tools that I had at hand where I was. And after I did my master's in sustainable environmental systems, I kind of had this choice in front of me. Do I go into a career in sustainability, or do I go back to architecture and bring that into architecture? And I think that really speaks to what Mark said and Peter said and everyone else also. This is not a career path. This has to be embedded in all of our careers. And I think that the example of finance, it's very important to mention that, because really when we actually think of sustainability as part of finance, as an integral part of finance, which it actually is, right? Like there's no finance if there's no earth, right? So if we can actually think about sustainability as an integral part of every profession, then I think we have a chance here. And I think I've been working with Weiss Institute and teaching high school students about building efficiency and design. And I mean, because I come from an architecture background, that's kind of what I focus on mostly. But I think what I want to convey is that whatever you do, it's just going to be, you have to love what you do. And also in this day and age, you have to be you have to feel good about what you are doing, for not only for yourself, but for the people around you, right? So I think that young people, I'm also young, but younger people realize this more and more, that it's not only a job, it's a lifestyle, because we live with our jobs right now. Our jobs are not just for money, it's our identity. And I think that when making a decision, just remember that, like it's going to be your identity for a long while. And it doesn't happen overnight. Obviously, it takes time to build, and I'm still building, and I'm sure everyone probably feels the same way. It's still growing, it's still building, but that's something that I keep in mind since I transitioned from just, being an architect and started to integrate more sustainability and action against climate change into my kind of world.
Right. Thank you. David, your thoughts?
I'm quick to tell people who ask, wow, you're doing a lot of stuff related to energy. I tell them I really don't know. I'm not an energy person. I don't know the first thing about energy. I know about finance. I know about how to structure deals that are difficult to do and require a lot of incentives. And to Mark's point, have kind of came into the space by applying those skills to looking at, how can we finance the gaps in the need to create financial structures that will make building energy retrofits possible. So, it's very important that all kinds of trades think about how to touch this space. But I think, that there are also some things that if you're a teacher and you want some takeaways from today, on what types of skills are needed out there, you know, the first person that gets paid is the engineer, right? The person that comes in, with respect to buildings, the engineer is the one that gives you the roadmap of what needs to be done, what can be done, cafeteria style list of things that the owner and investor can choose to do. And then you get into the various trades that are involved, the electrical trades, the building systems folks, the people who do air sealing and window, all manner of trades that are involved in making a building more airtight or upgrading heating and cooling systems are involved. And then we have some of the trades coming down the line. Right now, there's an incentive out there from NYSERDA for a new profession, the on-site building manager. At some point in the near future, let's say the building, you know, the building of the future will kind of be like the Starship Enterprise, right? You walk into a certain area, the power comes on, and there's a lot of remote things happening. So there'll need to be somebody that manages the controls of how the building operates and when and how power comes on, and managing cycles in these things. And that's another job. So, you know.
That's really cool. It sounds like there are going to be some unique opportunities going forward that maybe did not exist over the past 10, 20 years. So may have a different label than sustainability. And I think that's an important note for everyone to kind of keep an eye out for, that a lot of times these career opportunities, educational opportunities, may come under a different name than sustainability, but essentially they are sustainability. Let me switch gears to the UN sustainability, the UN Sustainable Development Goals very quickly, just with Mark to kind of raise awareness about it, and then we'll leave a couple of minutes for Kristy and Phyllis to wrap us up. So in 60 seconds, Mark, can you just give us a feel for to what extent the city may be considering the UN Sustainable Development Goals, which are 17 sustainable goals, including environmental and social ones that have been defined by the UN as a result of the Paris Agreement in 2015. And most recently, earlier this year, the UN launched what they're calling the UN Sustainable Development Goals business benchmarks, which are actually metrics that are intended to be benchmarks for every organization to follow. So with that introduction, go ahead, Mark.
Sure. So again, 60 seconds pretty quickly. I think it's important for everyone to understand that the sustainable development goals are an underpinning of a lot of the work that the city has done. As we have something in New York called 1NYC 2050, which is our long-term visioning for sustainability, both on the environmental and kind of social connectivity side for the city. So you can go and look up 1NYC 2050. And as you do that, you should know that it is embedded with SDGs. So the answer to whether or not the city is supporting that, will kind of work towards that, and is doing that, is absolutely yes, and it's already in case. There's also something that's important with this called the voluntary local review. So in addition to the city embedding those into our policies already, we're also the first city to commit to being an annual review by the UN of our progress on those goals. So we've since then incorporated and gotten some other cities to join, but we are committed to the success of that program, and also to changing the language by how a lot of global cities communicate and look at progress and track progress towards sustainability across the board. So yes,
That's
and
exciting.
We're fully on board.
Thank you very much, Mark. I was not even aware of that, so it was an interesting question for me personally to ask. I appreciate your feedback. I would encourage everyone to go online and check out the UN Sustainable Development Goals and the Sustainable Development Goals business benchmarks, explicitly titled. You may want to use it in your organizations operationally. You may certainly want to use it as an educational tool, and the UN does an excellent job of providing a lot of online infographics, and other materials that can be easily leveraged for educational purposes. I'd like to thank all of the panelists very much. I'm going to turn it over to you, Kristy. Kristy, you're on mute.
Thank you. Thank you to our amazing panel. I love learning from you. You're heroes for your partnership with our teachers, because our teachers are the people who are making our society a better place. They've always been here to help society evolve, and they're really being tasked again to make the world a better place. So we applaud you. It's really a lot of amazing work that you're doing. Thank you so much for all of your hard work this year and every day. We want to thank all of our amazing professional development trainers as well, Dr. Ingrid Zabel, Richard Reiss and his team, Archie and Theo, and our panelists, of course, Harun, Mark Chambers, Isil, Akgul, David Davenport, and Peter Kalmus, who had to step off. I wanted to give a final reminder for everyone who is looking for, to receive their CTLE credits. The link to the survey for CTLE credits is in the chat already. Please go ahead and download that, and we will be on for another 2 to 3 minutes after we're done, so that you can go ahead and download that. And a big thank you to Kyla, Sam, and Mike, our team at WISE, for all of their work to bring this conference to you on Zoom, as well as a big thank you to my partner at the WISE Institute, Sheila Beatty. Everyone attending today, you'll be sent a survey for feedback. And we hope to continue the conversation with you. I hope that you received a lot of new ideas to talk to your students and to bring into your classroom. If there's anything that WISE can do to help you, please let me know. We're there to bring sustainability to you. Thank you.